Black holes. The cosmic monsters that swallow everything, even light. Wormholes. The mysterious tunnels that could bend space and time. But what if these two aren't just separate, fascinating concepts in physics? What if they're secretly connected? For centuries, we've looked at the night sky and seen black holes as endpoints, cosmic voids from which nothing can return. At the same time, wormholes have been the stuff of science fiction, theoretical shortcuts through the fabric of the universe. Today, we're going to explore a mind-bending idea from the frontiers of physics, that a black hole isn't just a dead end, but a doorway. Could the most destructive force in the cosmos also be a hidden gateway to another place, another time, or even another universe? To understand this incredible connection, we first need to get a clear picture of what a black hole really is. Imagine a star many times more massive than our own sun, reaching the end of its life. Its nuclear fuel runs out and the colossal force of its own gravity takes over. The star begins to collapse in on itself, crushing all its matter into an unimaginably small, dense point. This creates a black hole, an object with a gravitational pull so immense that nothing, not even the fastest thing in the universe, light, can escape its grasp. At the very heart of this cosmic beast lies what scientists call the singularity. It's a point of infinite density and zero volume, where our current understanding of physics simply breaks down. The laws of space and time as we know them cease to apply. Surrounding this singularity is the event horizon. You can think of it as the ultimate point of no return. Once you cross this invisible boundary, there's no turning back. The gravitational pull is so strong that your only possible direction is inward, toward the singularity. It's the edge of the known universe, a one-way door to oblivion. Now, let's switch gears and talk about wormholes. These are less about destruction and more about connection. To picture a wormhole, imagine the fabric of space-time is a giant, flexible sheet of paper. Let us say you want to travel from a point on one side of the sheet to a point on the other. The long way would be to travel across the surface of the paper. But what if you could take a shortcut? A wormhole does just that. It's a theoretical tunnel or bridge that connects two different points in space-time. You could fold the paper, bringing those two distant points close together, and then poke a hole through them, creating a direct path. This idea wasn't just pulled out of thin air. It first emerged from the equations of Albert Einstein's theory of general relativity, proposed alongside his colleague Nathan Rosen back in 1935. They called it an Einstein-Rosen bridge. In essence, a wormhole is a mathematical possibility, a cosmic shortcut that could theoretically connect two distant galaxies, two different points in time, or perhaps even two separate universes. It's the universe's ultimate express lane, if it exists. This is where the story gets truly fascinating, according to the very same equations that describe black holes and wormholes. These two seemingly opposite concepts might actually be two sides of the same coin. Some theories in modern physics suggest that the singularity at the center of a black hole might not be an endpoint after all. Instead, it could be the entrance to a wormhole. In this model, the black hole acts as the mouth of the tunnel, swallowing matter and energy. This matter doesn't get crushed into an infinitely dense point, but is instead funneled through the wormhole's throat and spat out at the other end. This other end is what physicists call a white hole, a theoretical object that is the exact opposite of a black hole. Nothing can enter a white hole. Things can only exit. So in this scenario, whatever falls into a black hole in our universe could, in theory, reappear somewhere else entirely, perhaps in a distant corner of our own cosmos or even in a parallel universe. The black hole stops being a destroyer and becomes a transporter, a gateway hidden in plain sight. But before we start planning our interstellar road trip, there's a huge catch. Actually, there are several. The biggest problem is stability. According to our current understanding of physics, a traversable wormhole, one you could actually travel through, would be incredibly unstable. The moment it formed, the immense gravitational forces would cause it to collapse in on itself faster than the speed of light. Any traveler attempting to pass through would be crushed before they could even get a glimpse of the other side. To keep a wormhole open, you would need something with properties unlike anything we've ever observed. Scientists call it exotic matter or matter with negative energy density. This isn't just matter that's rare. It's matter that would have to possess anti-gravitational properties, essentially pushing space-time apart instead of pulling it together. While some quantum effects hint that such energy might be possible on a microscopic scale, we have no proof that enough of it could exist to stabilize a wormhole large enough for a person or a spaceship. Without this exotic material, the cosmic bridge collapses before it can be crossed. So where does that leave us? Are wormholes just a mathematical fantasy? Not necessarily. The quest to understand them is pushing the boundaries of modern physics. Fields like quantum mechanics and string theory are exploring the very fabric of reality at scales far smaller than atoms. Some of these theories suggest that tiny fleeting wormholes might be constantly popping in and out of existence in the quantum foam that makes up space-time. They would be far too small and short-lived for us to ever use, but their potential existence hints that the universe might be far more interconnected than we imagine. Perhaps one day a future civilization with a much deeper understanding of gravity and quantum mechanics will discover a way to find, enlarge, and stabilize these cosmic tunnels. Maybe they'll learn how to harness the energy of a black hole itself to hold a gateway open. The idea that black holes could be transformed from cosmic prisons into cosmic doorways remains one of the most tantalizing possibilities in all of science. So, are black holes the universe's ultimate destroyers, or are they its hidden gateways? Are they the end of the line or the start of a new journey? For now, the truth remains locked behind the event horizon, a veil we cannot yet pierce. The universe is full of secrets, and the true nature of black holes and their potential connection to wormholes is perhaps the greatest secret of them all. Until we find a way to look beyond that point of no return, the answer will continue to inspire our curiosity and fuel our imagination. Thanks for joining us on this journey through space and time. If you enjoyed this exploration into the cosmos, be sure to like, subscribe, and hit that notification bell for more science beyond imagination. See you in the next video.